Derive the Lagrange's equation of particle in a plane. Now let us consider the particle of the mass m moving in a plane. If O, x, y are the rectangular Cartesian coordinate and x, y are the components of the forces acting on the particle, then the given equation of motion of particle are mx double dot is equal to capital X and m double dot y double dot is equal to capital Y, which is equation 1. Now let q1 and q2 be the curvilinear coordinates. Then x, y are the functions of q1 and q2. That is, x is equal to x q1 q2 and y is equal to q1 q2. This is equation 2. Now differentiating 2 with respect to the t, we get x dot is equal to del x upon del q1 dot plus del x upon del q2 dot. Y dot is equal to del y upon del q1 dot plus del y upon del q2 dot, which is equation 3. Similarly, the arbitrary virtual displacement of del x and delta y are given by delta x is equal to del x upon del q1 delta q1 plus del x upon del q2 delta q2 and delta y is equal to del y upon del q1 delta q1 del y plus del q2 delta q2, which is equation 4. Now therefore the virtual work done by the forces is equal to delta w is equal to x plus delta x y plus delta y, which is equation 5. Now putting the values of delta x and delta y from 4 in 5, we get delta w is equal to x bracket starts del x upon del q1 delta q1 plus del x upon delta q2 into delta q2 bracket close plus y bracket starts del y upon del upon delta q1 delta q1 into delta q1 plus del y upon delta q2 delta q2 and taking the values of q1 variable with respect to the q1 collecting. So the bracket starts x del x upon del q1 y plus y into del y upon del q1 bracket close into delta q1 bracket starts and x into del x upon delta q2 plus y into del y upon delta q2, that is bracket close into delta q2, so which is equal to q1 delta q1 q2 delta q2, which is equation 6. Now where q1 is equal to x del x upon delta q1 y plus del y upon delta q1 and q2 is equal to x into del x upon del q2 plus y into del y upon del q2, which is equation 7, are the components of the generalized forces. The kinetic energy of the particle is given by T is equal to half bracket starts x dot square plus y dot square. Now therefore del T upon del is equal to mx dot into del x upon del q1 and my into del y dot upon del q1, which is equation 8, and del t upon del q1 is equal to x dot into del x dot upon del q1 dot plus my dot into del y dot upon del q1, which if as that is del dt upon dq1 is equal to mx dot del x upon del q1, my dot is equal to dy upon dq1, which is equation 9. Now since we know that from equation 3 and 4 that del x dot upon del q1 is equal to del x upon del q1, del y dot upon del q1 dot is equal to del y upon del q1. So differentiating equation 9 with respect to t, we get d over dt of bracket starts del t over del q1 bracket close is equal to mx dot del x upon del q1 plus my double dot del y upon del q1 plus mx dot do dt of now second one terms that is del x upon del q1 and my dot do dt of bracket starts del y upon del q1 bracket close. So which is equal to mx double dot into del x upon del q1 plus my double dot del y upon del q1 plus mx dot del x upon del q1 my dot del y dot upon del q1, which is equation 10. Now subtracting equation 8 from 10, we get d over dt of bracket starts del t over del q1 minus del t over del q1 is equal to mx double dot del x upon del q1 my double dot del y upon del q1, which is equation 11. Similarly we have d over dt of bracket starts del t over del q2 bracket close minus del t over del q2 is equal to mx double dot del x upon del q2 my double dot del y upon del q2 is equation 12. Using the equation 1 in 11 and 12, we get d over dt of bracket starts del t over del q1 minus del t over del q1 is equal to x del x upon del q1 y del y upon del q1, and d over dt of del t over del q2 is equal to del t over del q2 is equal to x del x upon del q2 y into del y upon del q2 and which is equal to d over dt of del t over del q1 minus d over dt of del q1 is equal to q1 capital Q1, and d over dt of del t over del q2 is equal minus del t over del q2 is equal to capital Q2, which is equation 13. Therefore are called as the Lagrange's equation of the motion of the particle in a plane.